Hi. In this lesson, we're looking at the area of any triangle, the area inside a triangle. But before we can look at that area, we need to know how to label the sides of any triangle. Say this is triangle ABC. That side AB is opposite the angle C over here. So we label that side with a small letter C. The side BC is opposite angle A over there. So we label with a small letter A. That side AC is opposite angle B over here. So we label that with a small letter B. Similarly, in this triangle DEF, so that is D, small letter D over there. That's E, small letter E there. F, small letter F over there. Another thing that we need to know before we can start with area of a triangle is how to see an included angle. If you are talking about two sides in a triangle, this side and this side, they meet at this vertex over here. So the angle over here is called the included angle. Included angle. So if this is a side that I'm talking about and this one, they meet at this vertex, this angle here. So this angle over here, we call it an included angle. Now let's look at what the area rule is all about. Area rule states that in any triangle ABC, the area will be half A times B times sine of angle C. Note angle C. Angle C is over here, and then they say the area of a triangle is half of A and B. So it's half of A times B, then sine of this angle over here. So the angle must be between the two sides that you label over here. I can therefore say, if I was looking at another angle, say angle B on this side over here, so the area of triangle ABC would be half of these two sides, so that this angle must be included. So it's half of A times C times sine of the included angle, in this case is B. Similarly, area of a triangle ABC is half, if I'm going to use that angle A over there, be half of B and C, P times C, so B times C, then times sine of the included angle over there, which is A. Okay, let's look at some examples. Now, they give us something like this. They say, find the area of this triangle. They give us the length. Let's fill in the length and see what you have. AC is 8. AC is 8 centimeters. So I've got 8 centimeters over there. BC is 12 centimeters. This is BC, which is 12 centimeters. Angle C is 30 degrees. Angle C over here is 30 degrees. I've got 30 degrees over there. They want us to work out the area of a triangle. We said to work out the area of a triangle, the angle must be included. That angle is included, and then we've got those two sides. Therefore, we can say the area of this triangle ABC is equal to half. Then we multiply by 8 centimeters multiplied by 12 centimeters. Then we multiply by sine of the included angle, which is 30, in this case 30 degrees. And therefore, the answer for us, we can plug it in the calculator and plug that. So what is it? It's a half 1 over 2, which is multiplied by 8, then multiplied by 12, then multiplied by sine 30 degrees is sine, then it's 30 degrees, and the answer is 24. The answer is 24, and this centimeter times centimeter, centimeter squared. That's our answer. Let's look at another example. Find the area of PQR. Angle P they give us is 50 degrees. P 50 degrees. Angle R is 70 degrees. Length PQ is 11. PQ is 11 centimeters or meters. And then QR is 6 meters. QR is 6 meters. Now I've got these two lengths here, but angle is included over there. How am I going to get it? By using grade 8 mathematics. The sum of the angles of a triangle is 180 degrees. So therefore this is 180 degrees minus the sum of those two, and then you get angle Q equals 180 degrees minus the sum of those two, 50 degrees plus 70 degrees, and your answer for angle Q is equal to 60 degrees. Aha, now we've got that one is 60 degrees. Now, can you work out now the area of this triangle? Yes, because there is an included angle and those two sides are known. Therefore, we can say the area of the triangle PQR is equal to half multiplied by side 6 meters multiplied by side 11 meters, then multiplied by sine of the included angle, which is 60 degrees. So the answer is, plug it in the calculator. So I've got a half times 6 times 11, then times sine of 60 degrees, and the answer is 28,6. 28,6, and meters times meters, meter square. That's our answer. Let's look at another example. There you go. They say the area of triangle KLM is 54 centimeters square. KL is 12 centimeters and LM is 18 centimeters. Calculate the possible sizes of angle L. I've drawn two triangles to show that it can be two triangles that we can have here. So let's try and fill these things in. The area is 54 centimeters squared. So the area, the answer of the area inside is 54. But the length is 12 centimeters for KL. Is KL. KL is 12 centimeters, and then LM is 18 centimeters. LM is 18 centimeters, and then let's fill in this one. So they said KL was 12, so I've got 12 centimeters, and then they said LM is 18 centimeters. There is my 18 centimeters. And now we want to find the size of the angle, and you can see it's an included angle and also it's an included angle over there. So we need two possible answers for angle L. Alright, so what do we know? We know that the area is 54. Now let's try and see what you get. The area of a triangle KLM is equal to, we know it's half multiplied by the two sides, which are 12 centimeters multiplied by 18 centimeters. Then we multiply it by sine of angle L over there. But we know what is the area of KLM. We're given is 54 centimeters. So I can say 54 centimeters squared is equal to a half times 12 centimeters times 18 centimeters times sine of angle L. Now how do I solve for sine L? I can cross multiply to there, so this way 2 multiplied by 54 centimeters squared will be equal to, now the 12 centimeter will divide on this side, so I'll have a 12 centimeters because it was times on this side. This one will also divide on this side, is 18 centimeters. So then I'll be left on this side with sine of angle L. Obviously the centimeters and centimeter square will cancel with that, so we'll eventually say 2 times 54 over 12 times 18 will be your sine of angle L. Now how do we find L? We know that to find the size of angle L, the sine will go to the side and then it will give us a sine of this. This is 2 times 54 over 12 times 18 is equal to angle L. Now let's see what we get. So we've got that, and now this is arc sine. We go shift with the sine. Sorry, let's shift with the sine. The fraction of 2 multiplied by 54, then over 12 times 18, and then we close there. We get an answer. The one that we get 30 degrees. Let's write that. So we get that angle L is equal to 30 degrees. It's an acute angle, so that one is acute. So that is one which is correct. What about this one, obtuse? Remember that sine is positive in two quadrants, in the first quadrant and in the second quadrant. And in the second quadrant, the answer for the angle, we say 180 degrees minus the reference angle, remember? So it's 180 degrees minus the reference angle, the angle that we get from the calculator. So therefore, another angle for L will be equal to 180 degrees. Subtract the 30 degrees and your answer will be equal to 150 degrees. Those are the two angles that we can get, the 30 degrees and 150 degrees. Now, for yourselves, can you now from Siavula textbook do chapter 6.5, where it says area, sine and cosine rule. You're still going to do the sine and the cosine rule later. Then you do exercise 6.10, numbers 1 only.